Hello everyone, welcome back to solving Leetcode problems. We are solving problem 9 today. So, palindrome number given an integer x, return true if x is a palindrome and false otherwise. So, if you look at first example here, 121, well, if you were to reverse 121, you would get 121. So, you know that must be a palindrome. Palindrome is just something that's the same forwards and backwards. Negative 121 wouldn't be, because there's the negative sign when you reverse it. That's going to go to the very end, so it's not the exact same thing. And 10 becomes 0, 1, so that's not going to be a palindrome either. Keep in mind, this problem specifically states that it doesn't specifically say that we can't convert it to a string, but the follow-up kind of implies that you should try to solve it without converting to a string. If you were to convert it to a string, this would be very easy because you could just return x equals and then convert x to a string. In Python, this is how you would reverse the string. So : -1, and then you would simply cast this back to an integer, and you could just return this, and this should, let's say if x is less than 0, we're going to return false. So then we know we're always dealing with a positive number. Okay, we've got I've added a couple test cases here just to get a better idea. But yeah, so we're not going to convert to a string, but we can actually keep this line because we can filter out all the negative cases. Since those are pretty straightforward, immediately you know if it's negative, then it's not going to be a palindrome. So now we need to figure out how we're going to do this. Well, you could probably do it recursively, but I think we're going to do it iteratively here. I remember I tried to do it recursively at one point and it became really weird. There's actually a test case here that I have where if you try to get the number where you trim the first and the last digit off, then you're going to get, for this example, we're going to get just 2, and 2 would be a palindrome. So if you try to just return that this is a palindrome, then you're going to return true and it ends up being false. So you can't directly do it without having something that maybe checks, how many digits are we expecting for this recursive call. And yeah, we're not going to get too much into that, but one thing we do want to know actually is how many digits we have here, because essentially what we're going to do is we're going to iterate over the length of the number divided by 2. So we're going to look at the first half of the numbers, and we want to just double check that this first one matches up with this last one, this second one matches up with the second last one, and so on and so forth. So that'll give us an O of n solution, which, well, actually it's O of log n if you consider n to be the integer that you're taking in. So that should be good enough. You can't really do any better because you have to check each digit at least once. So that's going to be as good as it gets. So first we're going to define a function within this function called getNumberLength. It's going to take in an integer n, and yeah, let's if n equals 0, then we're going to return 1. Otherwise, we're gonna give a nice variable name here. We're gonna initialize this to be 0, and we're gonna say while n is greater than 0, we're going to increment our number length by 1. We're going to integer divide our integer by 10. So dividing by 10 would get rid of the last digit, which would then give us, a number of length of our original number's length minus 1. So if we just keep doing that, well, we knock off a length from our original number, and then we add 1 to the result that we're going to be returning. So eventually, once we get down to 0, we should have exactly what the number length actually is. So we're going to have this here. And then, so now we know if x is less than 0, we're going to get the number length using that helper function. So we're going to call it with x. And now what we're going to do is we're going to iterate over the length of the number divided by 2. You could technically iterate over the number length. It's just, twice as, or this is twice as fast. It'll take half the time. So here, what we want to do is we want to get what the ith element from the front is and the ith element from the back is of our number. So let's say front equals, well, how are we going to get this? Let's say this 1 here. Well, actually, let's look at a little bit of a longer example. How are we going to get this 3? Well, if we divide by 10 to the 4, which is the number length minus 1. So x divided by 10 to the number length minus 1. Then we will get 3. But then on the second iteration, we want to also make sure that this works. So in this case, we'd have to divide by 10 to the 3, which is the number length. So that kind of tells us we need to be using the number length minus 1 minus I. So for every next number, we're going to decrement pretty much what power of 10 we need to divide by. But then you'll see that we're left with 34 in that second iteration. So if we just do mod 10, that should give us the front number, if I'm not mistaken. We'll find out later. And then for this back number, well, in the first case scenario, we need to integer divide by 1. So that would just be, if you kind of look at the previous line, we can guess that we're probably going to need to divide by 10 to the I. So in this case, we divide by 10, integer divide by 10, and then divide by 10 to the 2. So let's plug in I here. And then we're also going to want to modulo 10 for this. And then what we can do is we can check, okay, if front equals back, then we know that we have no issues so far, and this is still a palindrome. But if front is not equal to back, then we can return false. We know for sure this is not a number that's a palindrome. So in this case, let's say we get to I equals 1. Well, we get the second last digit and the second digit here. We check, okay, 0 and 2 are not equal. So we know that this is not a palindrome. They're going to return false. Otherwise, if we get through this whole for loop and we haven't returned false yet, then we know that we can simply return true. So let's see how this does. Okay, perfect. And we can just quickly print front and back just to show what we are actually getting in terms of the digits. So in this case, we don't need to check this middle number here because if there's just a middle number, then you know that we just need to check to the right and to the left of it because the middle number is going to match the middle number if it was reversed. But if we have something that's even length, so let's say 10 or 1221, we'll need to check these middle 2 numbers just to double check. So yeah, and you can see here we print out 2 and 2. But yeah, here we automatically print out false. We don't print out any digits. Here we print out 1 and 0, and we return false because they're not equal. Here we print out 3 and 3, then 4 and 4. And then we don't need to check the 1 because it's in the middle, and the middle digit is always going to be the same if there's an odd length string or odd length number. And then here we see that we get to 2 and 0, and we return false. So if we just comment that out and click submit. This should work. But yeah, that was a little bit annoying to solve when they say that you can't use strings, but it kind of gets you to think a little bit more about these. It's more just to test like your math skill. But yeah, that's pretty much it. If you guys have any questions about the solution, please let me know in the comments, and see you guys next time.